All right, good day, everyone. We'll be looking on sequence and series today. And as you can see here, this is a topic that we look at on the paper for paper 2 in the past paper questions. All right, this question is mainly at question 8 in paper 2. And so today we'll be looking on what it is that we need to do in order to get our 10 marks on that question in paper 2. All right, so when we look on sequence and series, we mainly focus on really two types, but there are several others, right? We mainly look on what we call the arithmetic progression. All right, so the arithmetic progression is normally given by the general formula A plus N minus 1, all in brackets, times D. Here, A is what we call the first term. That's the first term in the series. All right. N speaks to the position of the term in focus. And D is what we call the common difference. And this is normally the common difference is that it's really the difference between successive terms. So for example, if we were to look on even numbers, 2, 4, 6, 8, 10, right? Between successive even numbers, say 2, 4, let's look on 6, right? The difference between each successive term or pair of successive term would have been 2. So the difference between 2 and 4 is actually 2, and the difference between 4 and 6 is actually 2. So 2 is what we'd call the common difference, all right? In this sequence of numbers also, right, 2 would be the first term, right? And N here for each of these, 2 would have been in the first position, 4 would have been in the second position, and 6 would have been in the third position, and so on and so forth. All right. So let's look on the other one that we call the geometric progression. All right, so the geometric progression is different in that it speaks to a common ratio and not a difference. So let's look on this. So A, this is the general formula A, R to the N minus 1. In this case, A again speaks to the first term. R speaks to the common ratio. And N again speaks to the position of the term in focus. All right. The last time I saw a question like this on CSEC was, I believe it was May 2016, where we had the nuts and sticks questions. So far, I have not seen CSEC use geometric progression much. It is mostly arithmetic progression, or they would give you a formula that you would have to use in the sequence question. All right. Now we are going to be looking at some questions on sequence and series, and they are all past paper questions. I've compiled a group of them from 2016 to 2003. However, we'll be only looking at about 2 or 3 questions today. All right, so please pay attention to what is done here. All right, today with me, I also have Mandisa as my co-host. She'll be reading along with us. All right. All right, Mandisa, your turn.
Question 8. A sequence of figures is made up of unit squares with unit sides. The first three figures in the sequence are shown below. Draw figure 4 of the sequence in the space provided above.
All right, so in this case, many persons do not have a challenge when it comes on to drawing the next figure in the sequence. All right. Now, what I'm just going to do here is that I'm going to just add the different squares, unit squares to figure 3 to get figure 4, or to show you what figure 4 is like instead of redrawing it all together. All right. But first, let us look at what is happening. If you notice for figure 1, which is n equal 1, meaning figure 1 is in the first position, we only have one square. For figure 2, which is the same as n equal 2, where figure 2 is in the second position, that is what n means, the position of the term. So the 2 here means that the term is in its second position in the sequence or order. If you notice for figure 2, there are 4 squares added to the first square. So this time it makes it to 5 squares. All right. And let's look on figure 3, which is also n equal 3, meaning that figure 3 is in the third position. If you notice, we would have added 4 more squares to what figure 2 was, right? So each time we go up, we add a square to the different arms or the different parts that protrude on the figure before. So as I said, I'm just going to add the addition to figure 3 for figure 4. All right. So for this one, we'll add a square here. All right, forgive me with my drawing. We would have another square here, right? And we would have another square there and another square there. And essentially, this is what figure 4 would look like with the addition of the red squares. Remember now, CSEC is not marking you for drawing. What they want to know is that you're able to come up with a figure that flows in the sequence. All right. So that would have been our first 2 marks. And again, you would have to draw it in the space provided, but not to make edits to figure 3 like I did. All right. Matter of fact, let me just go ahead and just see if I could actually really draw this figure here on the space provided. All right. So first we have those. All right. So we'd have that. Then we'd have 1, 2, all right, 3. This side we'd have 1, 2, 3. Up here we'd have 1, 2, 3. At the side we'd have 1, 2, 3. So as you can see, the number of squares here is the same as here in where I made the edit. All right. And again, CSEC is not marking you for the drawing or the diagram itself. What they are marking you for is to see if it is that you know what the number of squares in this case would have been. All right. So we're moving along to the next part of the question.
Part B says studying the pattern of numbers in each row of the table below. Each row relates to one of the figures in the sequence. Some rows have not been included in the table. Complete the rows numbered I, 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 and IV.
All right, so in this part of the table, this is where now we would actually come up with our own formula for the different numbers or position of terms in the sequence. All right. Now, what I normally explain to persons is first, we want to do what the nth term would be first. So we need to come up with a formula for the nth term, right? Because all of the questions that we will answer is dependent on the formula that we come up with for the nth term. And as you can see, the nth term is in part 4, right? What does it mean to come up with the nth term? In the nth term, what we do, we create a general formula that suits, that you can use to answer all the questions above, even those that you would have been given already. Now, in this case, you did not get a formula to work with. So what we have to do is that we have to look on what it is that we have, the information that we have. So as you can see in our first column, you have figure. And the figure here is talking about the position of the figures. So as you can see, they have 1, 2, 3, 4. Those are the first 4 figures. Now, normally to get the number of unit squares for the 4th figure and also the perimeter for the 4th figure, it is not very difficult. But if we were to say find the 100th, find the number of squares or the perimeter for the 100th figure, it would have proven to be a challenge. So let's look on what we have here. So for the first figure, we have 1 square. For the second figure, we have 5 squares. For the 4th figure, we have 9 squares, right? And simply put, if you look on this, each time you're going up by 4. So from 1 to 5 is 4. From 5 to 9 is actually 4. So literally most times we can actually fill this information in before we can find the nth figure or the nth term, because this is just actually allowing us to see the pattern as it is. So for the 4th term here, the 4th term, the number of squares here would have actually been equal to 13 because we're going up by 4. So this would be 13. All right. We'll be proving this now in a little while. For the second part of the question here, as you can see, we're looking at the perimeter. So the perimeter of the first object or first figure is 4. Right? The perimeter of the second figure is 12. And the perimeter of the third figure is 20. If you look on the difference of these numbers, you know that there's a difference of 8. So each time you're going up by 8. So in the question here, right, we would be going up to 28. So from 20 to 28. Now we have this thing here where we have 45 here. Now, there are several ways that we can look at this, but I'm going to look at it in a methodic way. All right. So remember before we started this question, we were looking on the 2 types of sequence that CSEC normally uses. We will look on the arithmetic sequence. All right. And for this question is actually an arithmetic sequence. All right. So I'm going to be showing you how it is that you come up with a formula. So as you notice, the first term, let's look on the number of squares in that order. For the number of squares, we have first, we have 1, then we have 5, then we have 9. right? We have to remember that the general formula for the arithmetic progression is A plus open bracket n minus 1 times d, right? And we can use A to be the first term, D the common difference, and as you know, the position of each term will change or vary, right? So the position of figure 2 is not the same position as figure 1. So we do not normally look for n just yet. We look for the constants. The first term will not change its value. The common difference will not change its value. So in this case, the first term here, which is A, will be equal to 1, right? The common difference would have been the difference between the successive terms. So when we look on the difference between 1 and 5, this is actually 4. And if we look on the difference between 4, 5, and 9, it would also be 4. So if you notice, the difference between the successive terms is the same. And this is what we call D. All right? So D is actually 4. So once we have this information, we can just put it in the general formula and we can simplify it and then come up with our general formula for the nth term. So let's go. So for the first term is 1. So we'd have 1 plus open bracket n minus 1 times d, which is 4. We expand our brackets. So this would have been 1 plus 4n minus 4. And what we'd have here is that we'd have, for the number of squares, 4n minus, and this is 1 minus minus 4, so that would have been 4n minus 3. All right, so that would have been the general formula for the number of squares. So let's go ahead and just put that in. All right, so the general formula, and as I said, when we find the general formula here, is the general formula for the number of squares. So let's put that in. This would have been 4n minus 3. All right. Now for the perimeter, let's look on the perimeter. For the perimeter also follows an arithmetic progression. And as we said, the general form for the arithmetic progression is A plus 1 bracket n minus 1 times d. Now we want to look on the first 3 terms. For the perimeter, the first 3 terms would have been 4, 12, 20. All right. So in this case, the first term, which is A, would have been equal to 20. Not 20, but 4, sorry. Would have been equal to 4. All right. So the first term is 4. Let's look now on the common difference between the terms. So between 4 and 8, 4 and 12 would have 8. Thinking faster than I speak, guys. And this is 12 to 20 will also have 8. So the common difference here would have been 8. All right. So now what we can do is again come up with a generalization for the formula that can fit solve for the perimeter of any position of the figure. So here we go. So this now would have been A, which is 8 plus open bracket n minus 1. Oh, sorry, not my apologies. Here. The first term, sorry, would have been 4 plus open bracket n minus 1 times 8, which is a common difference. And here we just simplify, expand, and simplify. So this would have been 4 plus 8 times n, 8n, minus 8 times 1, which is 8. So in our final answer, we'd have 8n And seeing that we have 4 and negative 8, minus 8, we have minus 4. All right. So our general formula for this would have been 8n minus 4. All right. Now, once we have these formula, our formulae, our work is good as done. Right? So let's look on what it is that we are supposed to do in this. So I'm going to show you how you use the formula by doing question 3 first. All right, and the order in which you do the questions doesn't matter for CXC. Once it is that you have done it and you have done it correctly. All right, so for part 3, let us look on part 3 here. And what we'll be using is that we'll be using the formula that we have generated for this. All right, so let's go. So for question 3, it asks us to find the number of squares, which is right here, for the figure in the 30th position, and also the perimeter of this. Now, I know many of you would have been trying very hard to solve what this would have been by writing up some papers, coming up with all sorts of things. But the good thing is that you have your formula and you don't have to do that anymore. So let's go. So in this term, as you can see, when we look on the number of squares, the general formula for the number of squares is actually 4n minus 3. All right. And n here would have been equal to 30 because that would have been the position of the term. So what we'd have is that we'd have 4 times 30 minus 3. All right. That's as simple as that, guys. So 4 times 30, that would have been 120 minus 3, which would have been 117. All right. So 4 3s, 12. Let's just write it down so you guys can see. Minus 3 right here. That would have been 117. And that's it. And I just put in my 117 here. And that's it for the number of squares. Let's go over to the perimeter of the squares. Again, the perimeter has its own formula. And the formula here for the perimeter is actually 8n minus 4. So let's go ahead and get that done. So n here, as we know, would have still been 30. Right, because we're looking at the same figure for the number of squares as for the perimeter of the squares. So this would have been 8 times 30 minus 4. So 8 3s, as we know, would have been 24. So that's 240 minus 4, right? And this would have been 236. All right. So the perimeter for this, the 38th figure would have been 36. All right. So we're almost through now, guys. The next question, which is question 2, is what we have to work out. All right. So let me see if I can create some space for this working on our document. All right. Let's scroll down a bit. All right, good. So in this part of the question now, you'll have to use your transposition skills, because what are the things that we need? We know that the number of squares for this item is actually 45. We do not know the position of the term, right? Which would have been in the figure position, and we do not know the perimeter of the term. So what we have to do here is first find the position of this term, and after we have found the position of the term, we can simply use the formula for the perimeter and find the perimeter of that term. Now, seeing that we have the number of squares is equal to 45, what it is that we're going to do is use our formula for the number of squares along with 45 and then solve for n. So let's go. So what we do know is that we do know that the number of squares is actually equal to 4n minus 3. And at this juncture, we know that for that number of squares, it would have been equal to 45. All right. So in this case, it's a two-step process to find what n is. First, as you can see, we'll have to add 3 to both sides. And after we add 3 to both sides, we'll have to divide by 4. So let's go ahead and do that. So we add 3 to both sides. Seeing that we're subtracting 3, we would add 3 to both sides. All right, transposition. And this now would have been 4n is equal to 45 plus 3, which is equal to 48. All right. So what we'll have here is 4n is equal to 48. And in this case, if we have 4n equal to 48, all we need to do is divide by 4 for both sides. So 4 into itself 1, and 4 into 48 would be 12 times. So n in this case would have been equal to 12. All right. So that would have been the position of the term. And let us just go up here. And while you do it, you fill in the information in your diagram, all right, or in your table, so as not to forget. So the position of the term here would have been 12. And so with this, we can go ahead and find what the perimeter of this term would actually be. All right. Now for the perimeter of the term, as you can see, the general formula for finding the perimeter would have been 8n minus 4. And so what we do now, we know the value of n. All right. We know the value of n. So we can go ahead and we can calculate what this is. All right. So that's exactly what I'm going to do on this page. All right, the value of n is 12. So the perimeter, which is 8n minus 4, would have been the same thing as 8 times 12, seeing that n is 12 minus 4. Right? And 8 12s, guys, as you know, would have been 96. Right? 8 2 16, 8 1's 8, and carry 1, that would have been 96. Right? And for this, you would minus your 4. 4 from 96 would actually be equal to 92. All right. And guess what? That would have been the end of your question. And you would have had all 10 marks just like that. All right, so let's fill this in. So the perimeter of the shape is actually 92. All right. So people, there you have it. The first question is finished and it's worth 10 marks for each stage. You get 2 for the figure and 2 for each of the 4 pointers that you get down here. And that's your 10 marks. All right. Let's go and see what another question brings. All right. Let's go on ahead.
The first 4 figures in a sequence are shown below. Figure 1 is a single black dot, while each of the others consist of black dots arranged in an equilateral manner. Draw figure 5 of the sequence in the space below.
All right, again, ladies and gentlemen, as you can see, they're asking you to draw, right? And all you have to do is look on the pattern of the figures. So let's look at it again. So in this case, figure 1, as you know, would have been in position 1. So if we had an n for figure 1, n would be equal to 1. All right. Figure 2 is in position 2. Figure 3 is in position 3, or the third position. Figure 4 is in the fourth position. That means n would have been equal to 1 for figure 1, and n would have been equal to 2 for figure 2, n would have been equal to 3 for figure 3, and n would have been equal to 4 for figure 4. Now, as you can see, right here, the number of dots is arranged as an equilateral triangle if you were to trace it out. So we're just gonna go ahead and find out how, and just go ahead and draw the fifth figure. And again, ladies and gentlemen, I'm just going to take the short way out. As you can see, each time you go up, you add the number that the figure is. So for the first one, you started with 1 dot. When you go up to figure 2, you add 2 more dots to what you had before. All right, so this time we have 3 dots. When you go to figure 3, you still have figure 2, but you add 3 dots to it. And when we go to figure 4, as you can see, we add 4 dots to figure 4. So for figure 5, what we do is just add 5 dots to what it is. So 1, 2, 3, 4, 5. And so our figure 5 would look like this. All right, and that's 2 marks. All right. So let's move on. Go ahead.
How many dots would be in figure 6?
So again, this is what they're asking. How many dots would be in figure 6? So let's look on the number of dots in figure 5. So the number of dots in figure 5 would have been 3, 8, 6, and 4, 9, and 5, 10, 15. All right. So let's go again. 1, 3, 6, 10, 15 dots in figure 5. And we know for each figure we go up, we add the same amount. So for figure 6, we'd add 6 dots to what figure 5 would have been. And since the number of dots for figure 5 is 15, the number of dots for figure 6 would be 15 plus 6. All right, so let's get that. So this would have been 15 plus 6, which would have been equal to 21. So the number of dots in figure 6 would have been 21 dots. All right. Let's continue.